Here we go. Good old Anne. Suppose this mass begins from rest. I would probably mentally underline the term from rest. They want me to find time. So I said to myself, okay, they want me to find time. VI is 0, said from rest. They gave me a D of 4.8. I said, you know what? If I knew the acceleration, I could find the time. So even though this question is saying find time, I'm going to spend a lot of my time finding the acceleration. Let me pause for a second. How am I going to find A? Well, this is a job for a free body diagram. So I said, what are the forces acting? Definitely I have gravity down. I broke gravity up into its components of mg perpendicular and mg parallel. I said there's a normal force pointing 90 degrees to the ramp. Which way is it sliding? Down. So friction is going to be pointing up. And I said, who's winning? Well, mg parallel. Who's losing? Friction. What's that going to equal? ma. It's going to be mg. Have you found it yet? Oh, okay. Parallel minus mu times the normal force. I don't know the normal force. Oh, but look. Equals ma. I do notice that the masses are going to cancel somewhere along the way here. Little kids and grown-ups can ski together even when there is friction. I said it's going to be g sine theta minus mu g cos theta equals a. The acceleration is going to be 9.8 sine 53 minus 0.21 times 9.8 cos 53. And I found that the acceleration was equal to 0.21? 0.44. I don't know where the 0.21 came from. Thank you. So I got clear. 9.8 sine 53 minus 0.44 times 9.8 cos 53. Did you get an acceleration of 5.2316? And I'll carry extra sig figs. That 0 is a nice place to round off to. And now I can find time. I think time, I'm going to use d equals at squared over 2. Vi is 0. So I'm going to go t equals 2 times d over a square root. It's going to be 2 times d over a. Do I need to make a negative here? I don't think so, because that would give me a negative square root, and that would lead with problem. Oh yeah, I'm not slowing down, I'm speeding up. So 5.2316, although I'm going to use my answer button. 2 times 4.8 divided by answer button. Square root of that. Do y'all get 1.35 seconds, 1.4 seconds? If you got that, I would give you 4 out of 4. Otherwise, I would probably go something like half mark if I saw that, a half mark if I saw that. I would give you 1 mark for finding acceleration. 1 mark if, you know what, I'd probably go 1 mark if I saw that equation, and then 1 mark for the answer. If you got the wrong acceleration, but you did this successfully, that would get you 2 out of 4, and then we'd have to look and see where you made your mistake. What if instead of going down the hill, what if I was sliding up the hill? How would this first equation change? Sorry? How would this first equation change if instead of sliding down the hill, I was sliding up the hill? Which would change in my free body diagram? Friction would be pointing down the hill. And so I would have winner plus winner, not winner minus loser. It would be mg parallel plus friction equals ma. Okay. What if I was at rest? What would A be? 0. And so you would say, oh, mg parallel has to equal friction. I think that's about the only 3 things I can throw at you, down the hill, up the hill, or at rest. You good? Good. Number 2. Find the magnitude of the acceleration, and then find m1. Okay. Sam, how should I start this out? Darn right I should. It would be foolish not to start out with a free body diagram, wouldn't it? Absolutely foolish. Sam, it wants me to find the acceleration. Why can't I go winner minus loser equals m all A? Because that would give me A in the equation, which I don't know, and M1 in the equation, which I don't know. It would give me 2 unknowns. So instead, I go look at the mass that I do know. Sam, which mass do I know?
Mass 2.
Write an equation for that, please.
M2g minus T equals M2A.
I can find A. How would I get the A by itself? I'm going to divide by M2, and I'll find that A equals M2 5.9, G 9.8, minus 35.4. They gave me tension. That equals, divided by 5.9. I will give you a missing mass question. If I do, I have to either give you the tension or I have to give you the acceleration. Or I guess I could say at rest, which means A is 0, I guess. Use the mass that you do know to find what's missing, tension or acceleration. So I kind of walked you through it a bit in this one, Sam, by saying find A. I might not walk you through it on the test. I might just say find M1 and expect you to clue in. I can't until I find either A or T. Anyways, it's going to be bracket 5.9 times 9.8 minus 35.4, close bracket, divided by 5.9. Sam, did you get an acceleration of, holy smokes, 3.8 even?
Yep.
That's a fluke that it worked out nice. Normally carry 5 or 6 sig figs, right? If you got that, 2 out of 2. Otherwise, I would probably give you 1 mark if I saw that, half mark for the numbers, and a half mark for the answer. Sam, how can I find M1 then? Write an equation for M1. How? Who's winning? Who's losing?
M1.
What's that going to equal?
M1A.
Sam, how many M1s do I have?
2.
How many would I prefer?
1.
Get them to the same side. How many M1s do I have?
2.
How many would I prefer?
1.
You know what would be really neat? If there was a grade 9 mathematical operation that I could pull in my back pocket and change this from 2 into 1. And there is, Sam. What is it? What do we call that there thing there? Help them out, folks. Factor, how are we factoring? Which method are we using if we're being technical? Greatest common factor, or GCF, you abbreviated it in grade 9. So I can write this as T equals M1 bracket A plus G. Mr. Dueck, that looks scary. No, Sam, it's not, because how would I get the M1 by itself? Just what? Divide what over? We're going to use nouns and not pronouns. I want to get the M1 by itself, so looking for... Help them out, folks. Divide the bracket over. Right? 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 Right. So I'll get this. M1 equals T all over A plus G. LCM is least common multiple. So T was 35.4. A was 3.8 plus 9.8. 35.4 divided by 3.8 plus 9.8. Did you all get 2.6? Is that right? Kilograms. 2 marks. I would probably give you half mark if I saw that. Half mark if I saw that. I would probably give you a half mark if I saw that. And a half mark for the answer. If you got A wrong, but you went 35.4 divided by your A plus 9.8, I would give you 2 out of 2 for part B. A student of mass M places a bathroom scale on a skateboard. What does a bathroom scale measure? Not mass and not weight. What? Okay, so this question I'm really suspecting is a normal force question. He then rolls forward on level ground while standing on the scale. What will the scale read? More than big M, less than big M, or just M? I think if you're not on an angle, I think that, yes? Okay. The student now rolls the skateboard down a ramp, which is inclined at an angle theta, while standing on the scale, which is still on top of the skateboard. What will the scale read now? What happens to the normal force as the angle increases? Bigger, smaller, or stays the same? That's really what this is asking. Yasmin, you know what this is a good job for? I think I'm going to do a free body diagram. So I'm going to really, really quickly just draw. There's the skateboarder. Whee! What are the forces acting on the skateboarder? Get the obvious one. And I would break that up into okay. Oh, and normal force. I would say something like this. The normal force is equal to mg perpendicular. If you mentioned that somewhere, I would give you, in this 2-mark explanation, a 0.5. Then I would say something like normal force equals mg cos theta. As theta increases, what happens to the normal force? Why? How could I convince myself? Let's look at the extremes. In part A, when theta was 0, what was the normal force equal to? mg. What if we hit 90 degrees? What would the normal force be equal to? Yeah, 0. So if we went from mg to 0, as theta increases, what happened to the normal force? Say the answer, then you said again. No. Decreases. Okay. As theta gets bigger, normal force gets smaller. So as theta increases, normal force decreases. If you said something like that and it makes intelligent sense to you, you could give yourself 1 mark for circling less than m, because the scale will show you lighter. And then if in your explanation, if you did a free body diagram and somewhere that you said that the normal force equals mg cos, and as theta gets bigger, it gets smaller, I would take that. If you made up some numbers, if you said, I'll let m be 40 kilograms, I'll let theta be 10 degrees, then I'll let theta be 40 degrees, and I'll show you that mg cos 10 is bigger than mg cos 40, and therefore it gets smaller as we increase theta, I would give you full marks for that. Did anybody try something else? If you did, lawyer with me afterwards. I'll look at it and I'll tell you what you would get. But otherwise, this page is worth 1, 2, 3. This page is out of 4. Find the acceleration. This is a job for a free body diagram. Normal force number 2 to go with mass number 2. Tension. No friction. Okay. Find the acceleration. Who's winning? I'm not sure. What's the tug of war between? The tug of war is between M1G and M2G parallel. So Sam, I'm going to really quickly just crunch those. M1G would be 11 times 9.8. Oh, 11 times 9. 0.8. M2G, 2 lines, sine, would be 10.5 times 9.8 times the sine of 58. I think M1G is the winner. Oh yeah, very much so. So this whole system is accelerating that way. Who's winning? Now I know. M1G minus tension plus tension minus M2G parallel, that equals M all A. Oh, love it when I lose tension. Can never get enough of that. Ooh. So A is going to be M1G minus M2G sine theta all over M1 plus M2. It's going to be M1, 11 times 9.8 minus 10.5, I think that's what it was, times 9.8 sine 58 all over 11 plus 10.5. Is this a fraction? Yep, more than one thing on the top. 11 times 9.8 minus 10.5. 11, Mr. Dueck. Why is that 1 not working? 11 times 9.8 minus 10.5 times 9.8 times sine of 58 divided by bracket 11 plus 10.5. Now the plus didn't work. Did you all get... Oh, what's my built-in error check? If we cut the rope to M1, what's its maximum possible acceleration? Yeah, so it's going to be less than 9.8. You get 0.955? If you got that, 2 out of 2. Otherwise, I would give you a half mark for that line, a half mark for that line, a half mark for the numbers, and a half mark for the answers. Find the tension in the rope. I'm definitely using M1. M1 minus, oh, no, Mr. Dueck. M1G minus tension equals M1A. Time for the swappy dance. I'll get M1G minus M1A equals tension. So tension is going to be M1 11, G 9.8 minus M1 11, G A 0.955, but I'm going to use my answer button. 11 times 9.8 minus 11 times answer button. Do y'all get 97.3? Newtons. 2 marks for that. I would give you half mark for that, half mark for that, half mark for the numbers, and a half mark for the answer. But if you got the right answer, 2 out of 2. Ooh, to hold this stationary, what would the minimum coefficient of friction need to be? So what we would be saying then is M1G minus M2G parallel minus friction equals 0. Where is the mu hidden? Inside which term there? Where is the mu hidden inside of? Friction. I'll get friction by itself. M1G minus M2G, 2 lines, is sine, equals friction, which is mu times the normal force. I don't know the normal... Oh, first of all, to get the mu by itself, I'm going to divide by the normal force. I don't know the normal force. Oh, but look. It's going to be M2G perpendicular. I'll get mu equals M1G minus M2G sine theta all over M2G perpendicular Mu is going to be M1, 11, G, 9.8, minus M2, 10.5, G, 9.8, sine, what was theta, 58? All over M2, 10.5, G, 9.8, cos, 58. (11 times 9.8 minus 10.5 times 9.8. The sine didn't show up, Mr. Dueck. Sine 58. Forgot to write the trig function. Oh, again. Wow. My one key is not working right today. Probably need to replace the keyboard battery. Sine 58. Close off the sine. Close off the top. Divided by bracket 10.5 times 9.8 cos 58. Do you get 0.377 if I round off properly? Yeah. Cool. Couple more, we're done. Example 5. Well, they also want me to find a coefficient of friction. Okay. This is a job for a free body diagram. MG down, MG perpendicular, MG parallel, normal force, and I think friction is going to be pointing up the hill. I would say, who's winning? MG parallel. Who's losing? Friction. What's that equal? MA. I want to get the mu by itself, and that has friction. Friction contains the mu, so I think on my next line, I would go MG parallel minus MA equals mu times the normal force. I don't know the normal force. Oh, but look. I would get the mu by itself. Mu is going to be MG, two lines, is sine theta, minus MA all over MG perpendicular of cos I do. Uh-oh. Oh, well, for starters, I could have canceled out the m's somewhere along the way. You don't have to, but they will cancel. Mr. Dueck, I thought the m's only cancel if there's an m in everything, or if it's a fraction and there's an m in everything in the fraction, the m will cancel. So I can cancel out the m's. Did they give me the mass of the skier? They did, so you could also leave the 45 in. Problem, I don't know A. Or do I? Well, V final is 8, V initial is 0, V final is not 8, Mr. Dueck. Time is 8, Mr. Dueck. V final is 20, Mr. Dueck. You know what? A equals VF minus VI over T. It's going to be 20 minus 0 over 8. I can do that in my head. 20 divided by 8 divided by 4 divided by 4. It's going to be 5. Is it 2.5? And now I walk over here and I'll get mu equals 9.8 sine 16 minus 2.5 all over 9.8 cos 16. 9.8 sine 16. Oh, I have to close off my trig function. Minus 2.5 divided by bracket 9.8 cos 16. You get a mu of 0.021, which seems small. And that, oh, wait a minute. Are we skiing on snow? Should be small. So I wasn't creeped out by that after all. So 0.021. If I go to 3 sig figs, it would be 0.0214. Units. Are none. Okay. In terms of part marks, what did I make this worth? 4. I would definitely give you 1 mark for finding A. So that leaves me 3 to play with. I would probably go something like this. 1 mark for that, 1 mark for that, and 1 mark for the answer, or something like that. Last one. Free body diagram, you say. Oh, they want me to draw the free body diagram down here. On your test, I will ask you to draw a free body diagram for one of the written questions. You can label the picture too. I won't mark that. I will mark whatever you put in the blank space underneath where I tell you to draw the free body diagram. So, what are the forces acting on this hay bale? Get the obvious one. F applied. What else? Normal force bigger, smaller, or the same size as mg? Why can't it possibly be the same size? Can you see, Julie? There's an extra vertical component. We haven't drawn it in yet, but there's an extra vertical component. Normal force is going to be smaller. So if you did not make the normal force noticeably smaller than mg, I would take off some marks, and I'll show you how that's going to work in a second. What else? Friction? How big? Well, the fact that it says prevents it from moving means my acceleration is what? As a number exactly? So that means the forces are, I'm looking for a word that begins letter B. I would be drawing friction. So if I broke this up into its components, friction should be just as long as Fx. So how many blue lines did I draw? How many marks is this question worth? 2. I will give you a half mark for drawing mg, a half mark for drawing F applied, a half mark if you drew the normal force shorter than mg, and a half mark if you drew friction about the same length as the horizontal component of your applied force. That's what you need to do to get 2 out of 2. And you know what? Normally I would label my diagrams, but since I've just done a nice lovely free body diagram, well, no, wait a minute. They said draw the free body diagram here. I'll leave it pristine. I'll go up here and I'll quickly resketch this. So I have mg, normal force, F applied. Now I'm definitely going to put the components on the diagram. There's Fx, there's Fy, and friction, good yawn, same size as Fx. Kira, what does B want me to find? My first thought, don't write this down, was I went, okay, friction equals mu times the normal force, and I came to a grinding halt. Why? No mu. Okay, let's try doing it with forces. Ah, are we accelerating? Because we're at rest. So I said, you know what? The horizontal component of the applied force has to be the same size as friction. So even though I don't know friction, I can find Fx, which will be the same size. How would I find Fx? Which trig function? Well, I think Fy was sine, so Fx is going to be which trig function? Do you know? Of course you do, right? I said, aha, friction is going to be F applied cos theta. So now I can plug and chug. It's going to be 140 cos 28. And I got friction is 123.61. I'm going to write 124, but I'm going to store this on my calculator. You know what? Actually, I'm going to write this out and then I'll round off. 123.613, which is 124 newtons. If you got that, I would give you 2 out of 2. Otherwise, I would give you 1 mark if I saw that you had had that aha moment. I would give you a half mark for bringing in the cosine and then a half mark for the answer. Calculate the normal force. I don't know the normal force, and it's not mg. But Julia, is it sinking into the ground like quicksand? Is it flying through like Superman? Then everything down has to equal everything. So everything down has to equal everything up. How would I get the normal force by itself? Subtract the Fy over Fyi. So the normal force is going to be mg minus Fy. The normal force is going to be mg minus F applied sine theta. It's going to be, what was m, Mr. Dueck? 55 times 9.8 minus 140 sine 20. Let's try that again. 28. 55 times 9.8 minus 140 sine 28. Did you get 473.2739? 473.274? 473.274, which is going to be 473 newtons in my final answer. Then D says, find the minimum coefficient of friction. Well, friction is mu times the normal force. Kira, how would I get the mu by itself? What did I find in part B? Friction. What did I find in part C? Normal force. And that's why part D was only 1 mark, because you already have found everything. It's going to be fairly plug and chuggish. It's going to be 123.613 divided by 473.274. 123.613 divided by, okay, I'm going to use my answer button for the normal force since I have that sitting there. And I got a mu of 0.261. Is that correct? People nodding? Units? None. So that's had some teeth, but hopefully not too many. I would consider all of these fair game. And hopefully, Dan, you're noticing it's becoming kind of repetitive. Okay, cos, okay, sine. Oh, are we accelerate? Who's winning? But this method that I've taught you of the tug of war and a good free body diagram, it'll bail you out of the vast majority of... I could throw far more complicated stuff at you. We can handle it. It would just be longer, and I'm not interested in giving you a question that takes 15 minutes of writing to assess the same skill as a question that takes 5 minutes of writing on a test. Okay? Can you give yourself a lovely score on the front page out of 29? If you need to lawyer with me, now is the time.